So in every building automation system, in every building I should say, there's an HVAC system. HVAC systems by nature use a lot of energy to mechanically move heat from inside the building to outside the building. So sometimes the outdoor air is actually better than what we're trying to cool it down to. In that case, you use something called an economizer.
So what is an economizer system? An economizer system is used in HVAC systems to save energy, and it's going to use the outdoor air temperature to cool your building. And there's two different types. You got the air side economizer, that's using outdoor air, and it's just bringing it straight into your building. If it's cooler out than your indoor temperature, that's what you're going to use. Water side economizer, it's also going to use the outdoor air, but it's going to use that to cool your water for your chilled water loop instead of using the refrigeration cycle. It's going to save you some energy and only have to use pumps instead of compressors. Alright, so here we have the air side economizer diagram. This is going to be your rooftop unit mounted up on top of your building. Right here you're going to have fins. Usually there's going to be a rain hood to keep weather out and not have to worry about sucking in water inside your system if it's raining outside. So you're going to have these fins that are controlled by actuators. That's all going to be through your building automation system on how far those dampers are open. That's going to be bringing in outdoor air if the conditions are right. You have an outdoor temperature sensor here. That's going to not only monitor temperature but also humidity. Those are two big factors when you're using outdoor air. That's going to bring it in through filters. It's going to use the fan, push it into your supply air duct. Heating and cooling coil aren't going to be on. They're not going to be used when you're doing outdoor air.
So here we got two diagrams of water side economizers. This one's a bit more simplified than that one, but this in essence is how a water side economizer works. It's basically kind of another chiller, but it doesn't have a compressor on it. So you would have, in addition to your chiller piping on your condenser water loop, you'd run another set to a big heat exchanger. So when you're ready to use water side economizer mode, you turn your cooling tower on, send that nice cold water from the tower through the water side economizer heat exchanger, and then that's going to pull heat from your chilled water loop, transfer it to that water, and then take it outside. The key to making these things very efficient is having the supply temperature coming off the tower lower than the design temperature of your chilled water loop. That will greatly aid the heat transfer. This one over here is in series. That means if you want to run your water side economizer and your chillers at the same time to help maybe lower the chiller load, you'd have to run the heat exchanger on the chilled water return, versus this one, which is in parallel, which means this chiller cannot run when the water side economizer is running. It's either only economizer or only chillers. This setup's a little more common only because you can simultaneously run chiller plant and the water side economizer, which can also help save energy because you're not running the chiller at full capacity. You might be able to get away with running the chiller at 50% capacity versus 100%.
Alright, so why are you going to want to use an economizer on your system? It's going to save energy. You're only going to be using pumps to circulate water on that water side economizer, and you're only going to be using fans to pull in that outdoor air for your air side. Outdoor air temperature and humidity are lower than indoor air, so depending on where you're at, if you're in like a northwest region, it's going to make sense to use that outdoor air. Also, fresh air requirements. Commercial buildings are required to have a certain CFM of outdoor air coming in for air exchanges. So if you can just use strictly outdoor air to cool your building, why not? It's just going to be easier. You don't have to worry about that minimum. Just go strictly outdoor only. And it's also going to save money for the building owner and the businesses, and it's also going to give your mechanical systems a break. So if you need to work on something on your air handler, if you're using strictly outdoor air, you can bypass some of the components on that air handling unit.
Some of the advantages of economizer systems, number one is save energy because you're not running compressors. Or in the case of a water side, you're not running compressors at full capacity. Either or, you're still saving energy. Another big advantage is you're bringing that fresh air in. So if you're in a region where it's kind of mild and you're sometimes worried about that minimum fresh air requirement, once you go into economizer mode, you don't need to worry about that. You're running on basically 100% outside air. You are going to get those air changes per hour, no problem at all.
So some disadvantages to an economizer system is the outdoor conditions. So depending on where you're at in the country, it might not make sense to use outdoor air because of the humidity. Another thing for a water side is you have to worry about freezing from pipes going to your tower and going back in the building. They can rupture when they freeze, crack, you have to worry about leaks, and you can flood out your building. So there's a lot of money involved if something like that would happen. And also your outdoor air quality is a huge factor when you're using outdoor air to cool your building. If you're around factories, a lot of traffic, cities, you have to worry about bringing in pollution pretty much inside your building, so you might have to add filters or some kind of other filtration device to get rid of that toxic air before you bring it inside your building. So here's a map of North America with your best locations for an economizer. Over here on the left side of the screen, you're going to see it's our air side free cooling map. Down in the south, you're going to see that it's red, which is where you can run like the least amount of hours. It's just not a good spot to be using the air side economizer. You're not going to be efficient. You're going to be probably wasting more energy than saving. You can see up in the northwest as your main reason you're going to be running that air side economizer. They're going to have mild temperatures. You can run that up to 8,500 hours, so it's a great option for your system. Over here on the right side of the screen, you're going to see it's our water side free cooling map. Now, I don't know if we stated this earlier, but air side is going to be a lot more efficient than your water side. So you can see on the map here, it's going to reflect on the image here. You can see that that red line is creeping up on the United States a lot further than over on your air side. Red line here is only in like the Carolinas compared to over here, red's reaching Pennsylvania. So it's just not as efficient way to save energy with the water side. Up in the north here, it's a little better. You're not really seeing the blue until you hit Canada.
The main reason airside is more efficient is because airside is using the direct air, taking it right from the outside through the air duct into the building. The water side has to run it through that heat exchanger. Every time you run water or heat through a heat exchanger, there is a little bit of loss to it. So the reason a lot of green is here, that's just showing physical heat exchanger loss. And in some buildings, they're okay with that because they can only use a water side economizer. But a lot of buildings, you're going to see air side economizers strictly because they can get more hours out of it for their location.
So what types of buildings are going to be using the economizers? You're going to see it in schools, office buildings, data centers, government facilities, hospitals, grocery stores, pretty much anything commercial. You're going to see air side or water side economizers being used. I'd say most of the time you're going to see air side. Here's an example. You have a large rooftop unit here. This is your rain hood covering the area where the outdoor air is going to be going inside the unit. Has fins connected to actuators. That's going to be used with controllers to modulate how much outdoor air you're pulling inside that unit, going through the filters, sucking in with the fans through your supply air ducts.